Welcome to The Explainer. Today, we are diving into one of the biggest threats in cybersecurity, privilege escalation. So what is that? Imagine a hacker gets into your company's network with just a visitor pass, but then they find a way to turn that pass into a master key that opens every single door. That, in a nutshell, is what we're talking about. It's a huge goal for any attacker, and we're going to break down how you can stop them cold.
So here's our game plan. First, we'll look at what attackers are really after, the keys to the digital kingdom. Then we'll get into the nitty-gritty of authentication versus authorization. Trust me, they're different, and both are super important. After that, we'll unveil your single best defense, the principle of least privilege. We'll even see how this all plays out in the cloud, and we'll wrap it all up with a practical checklist you can actually use.
Okay, let's dive right in. To really get this, we have to understand what's at stake. Think about your entire digital setup. It's not just a bunch of servers and code, right? It's a fortress. And inside that fortress are the crown jewels, all your data, your applications, and all that customer trust you've worked so hard to build. So the biggest question we have to answer is who gets a key and what doors can they open with it?
I mean, just think about that for a second. A bank where anyone can just walk in, go anywhere, and take whatever they want? It would be total chaos. And that's exactly what your system looks like without good access control. All your most sensitive data, your critical infrastructure, it's just a free-for-all. It's the ultimate nightmare scenario, and it's precisely what we're trying to prevent.
And you know where this nightmare usually starts? With one single shared root account. The keys to everything. When everyone shares that one all-powerful account, you have zero accountability. One person makes one tiny mistake, a slip of the finger, a wrong command, and poof, the whole system can come crashing down. We're talking deleted databases, applications going offline, gone. And the worst part? You have no idea who did it. There's no trail, just chaos.
So how do we stop that from happening? Well, we build our defenses on two fundamental pillars. To properly lock down our digital kingdom, you really just have to answer two simple questions.
And here they are. It really boils down to this. First, who are you? The system has to be sure you are who you say you are. That's authentication. But then comes a second question. Okay, now that I know who you are, what are you actually allowed to do? And that is authorization. You can't have one without the other. They're two sides of the same security coin. Right, so let's break that down. Authentication is basically the bouncer at the front door. You walk up, you show your ID, your username and password, maybe a security key, and the system checks its list to make sure you're on it. It's all about proving you are who you claim to be.
Okay, so you're past the bouncer, you're in the building, now what? That's where authorization kicks in. Just because you work there doesn't mean you can just waltz into the secure data center, right? Your key card only opens certain doors. A DevOps engineer? Yeah, they probably have access. Someone from the marketing team? Not so much. That's authorization doing its job.
Now this next part is, well, it's the whole ballgame. If there is one single idea, one philosophy that is more powerful than anything else for stopping privilege escalation dead in its tracks, this is it. It's called the principle of least privilege. The idea itself is actually super simple, but it is incredibly powerful. You start with nothing, zero access. By default, a brand new user or a new application can't do a single thing. Then, and only then, do you grant the absolute bare minimum permissions they need to do their job. Nothing more, nothing less. And let me tell you why this start with zero rule is so critical. Think about it. It is way, way easier to give someone a little more access when they ask for it than it is to try and take away extra permissions after something has already gone wrong. Trying to clean up that kind of mess after a breach, it's a total nightmare. So you always start small. It's just the smarter, safer way to play it. Okay, that sounds great in theory, right? But what does this actually look like in the real world? How do you apply this to a massive, complex system like AWS or Azure, where you might have hundreds, maybe thousands of users and services, all needing access to different things? Well, the answer lies in a service that pretty much every major cloud provider offers, Identity and Access Management, or IAM for short. The best way to think of IAM is like the central command center for all your cloud security. It's the one place you go to set all the rules, who can do what, to which resources, and under what conditions. Now, here's the real magic, the thing that makes this work at scale. You don't assign permissions to individual people. I mean, can you imagine trying to manage that for hundreds of employees? It'd be impossible. Instead, you create roles or groups.
You'll have a developers group, a data analyst group. You give the group the permissions it needs. Then you just pop people into the right group. New engineer starts, add them to the group. Someone leaves, remove them. It's so much cleaner and way, way more secure.
And this right here is the end goal. Look, even your administrators shouldn't just have a single God mode account. That is just asking for trouble. Instead, they should have specific limited roles. You might have one admin role for managing servers and a totally different one for databases. Why? Because it limits the damage. If one of those admin accounts gets compromised, the attacker can't destroy everything. We call that containing the blast radius.
Okay, so we've covered a lot of ground. Let's pull all this together into a straightforward, actionable checklist. These are the things you can do right now to harden your own systems against privilege escalation.
First things first, protect the crown jewels. That main root account, that's the ultimate target. An attacker wants that more than anything, so lock it down. Slap multi-factor authentication on it, and then put it away. You should never use it for day-to-day work. It's for emergencies only, like a break glass in case of fire situation. Everything else gets done through roles and groups.
All right, next up, you have to be disciplined. This is not a one-and-done thing. You need to enforce least privilege relentlessly. And here's a pro tip. Avoid handing out permanent keys. Instead, use services that can generate temporary credentials that just expire after a few hours. And this is a big one. You have to review permissions regularly. Seriously, set a calendar reminder to check who has access to what. Because that access someone needed for a project 6 months ago, if they don't need it anymore, it's not a tool, it's a security hole.
And finally, you can't protect what you can't see. It's that simple. You need visibility. So turn on your logging tools. Things like AWS CloudTrail, for example. Think of it like a security camera system for your entire account, recording every single thing that happens. Keep an eye on your network, and this might sound weird, but watch your bill. A sudden massive spike in your cloud costs is often one of the first red flags that an attacker is in your system.
So after going through all of this, the threats, the principles, the checklists, it really all comes down to one final critical question you have to ask yourself about your own systems.
So really think about it. Is your security a fortress that you've built deliberately, brick by brick, with layers of thoughtful protection? Or is it more like a house of cards, just waiting for one wrong move to make the whole thing fall apart? Because at the end of the day, real security isn't about buying some fancy tool. It's a mindset. It's a culture built around this principle of least privilege. And that is how you build a fortress that'll actually stand the test of time.